Hi everyone, and welcome to electricity lesson number 5 on series circuits. So today we're going to be doing a warm-up just to understand the overall idea or the key concepts of electrical circuits. And then we're going to go through our lesson 21 on series circuits. So let me just show you which handouts we're using. So lesson 21, the one with the pizzeria picture, okay, and it's on starting on page 129. 129. Okay, so by the end of this lesson, you will understand that series circuits have only one path to follow. So this means that the electric circuit, there's no choice in where the electrons go. They are all forced to follow one path only. So that means that they are either on or off, okay? So this also means that either all items are all on or all items are all off, okay? And I'll go into that a little bit more, okay? Next up, each item shares electrical pressure. So this means that, for example, if I add more bulbs, each of those bulbs, all of the bulbs will have to share the electrical pressure, so like the amount of electricity they get, and then they'll all get dimmer and dimmer and dimmer. So that means the more light bulbs I add, everything gets dimmer. Okay, so we're going to go through our lesson together, and then I'll do a phET simulation practice. So I've gotten some good feedback, and students seem to like the simulation, and I just find that this is really good, especially for this one, just to see how each light bulb gets dimmer as we add more. Okay, so we will be doing that. And then finally, after you review everything and you feel pretty comfortable, please click right over here for a direct link to the online quizzes assignment on series circuits. A reminder again to sign in with your TDSB email account. Okay, let's get started. Okay, so over here, we've got a picture of these sort of Broadway lights, okay? So these are all in series. That means that this sign would either be all on or all off, okay? And the best typical example of a series circuit is actually old style Christmas lights, okay? So I'm very sorry if you don't celebrate Christmas, but I just find that this example is probably the only one that we can relate with, okay? Because there's very few things that are wired in series circuits that we can relate with, just because they are so uncommon, because all of the items are either on or off, okay? So I remember this happening when I was a kid, okay? So this is all in series. So all of these light bulbs are connected in one line, okay? So there's only one wire passing through all of this, okay? So the problem with this is that inside the light bulb, these are old style light bulbs. These are not the newer style LED light bulbs. Okay, so inside here, there's a reason why the circuit symbols for a light bulb were like this. Okay, there's literally a wire going through the light bulb and it's connecting metal with metal. Okay, and it's in the glass enclosure. Inside here, the filament or the wire, like a filament is a very, very thin wire, it was made of tungsten. Everyone say tungsten. Okay, so on the periodic table, tungsten is a metal. It's an element, okay, and it has the symbol W. So here's tungsten, W. So it is a metal that has a high resistance, so that way when you pass the electricity through it, it will actually glow very, very brightly. Now, these traditional light bulbs also got very hot when you touch them. So literally what's happening is that when you put this and you screw this into the socket or whatever, there's a wire that connects to the socket. Then there's a wire that, as long as the metal touches the base metal right here, it will travel up, go through this metal filament made of tungsten. As the electricity goes through there, it glows really, really hot and it glows brightly, which produces light. Then the electricity, because we now know about good circuits and bad circuits, right? So as long as everything is connected, it's a good circuit, right? So if everything is connected and all the wires are still okay, it'll pass through here, go back through the wire that's, in the socket or in the cord, and then the circuit is complete. Okay, now what would happen is that if this light bulb actually, if this little filament that is very, very thin, if it burns for long enough, the light bulb will burn out. Okay, okay, so when this light bulb burns out, it will actually break. Okay, so it'll actually break apart. And then one of the ways that you can actually tell if a light bulb is burnt out as opposed to just malfunctioning is that these old style light bulbs, you would often be able to shake them and you would hear the little piece of metal rattling around. Okay, so a lot of your parents might also remember this and be able to talk about it. Okay, now because of these energy efficient light bulbs that are selling in all the stores now, we are not used to this because there's a different sort of mechanism. Okay, so it literally means that when this light bulb burns out, there's a break in this wire. It's almost acting like a switch, like an open switch. So if you could imagine this light bulb, or let's just say this light bulb breaks, okay? It 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 burns out, which means that this little piece of metal right here breaks apart and it opens up like an open switch. Now we know that in an open switch, either all devices are going to turn on or else all devices will turn off. Okay, so I hope you understand that from when we talked about good circuits versus bad circuits, right? So can you imagine the problem we might have if we had, for example, 100 light bulbs? The problem is that I don't know, especially since when you shake these around, the filaments were so small that we couldn't really hear it very well. Okay. Or also, if you shake them too hard, you might actually break the filament, okay? So that was the problem with these. Now, if you can imagine, because this acts like an open switch, that means everything shuts down. So that means that none of these lights are on. So we can't even tell that this is the light bulb that is broken, that is burnt out. So I remember doing this as a kid. We would start at the beginning. We would have one light bulb that was brand new that we were hoping worked properly. Okay, then we would have to take this light bulb out, put the new light bulb in, and if the whole thing didn't light back up, we knew that this isn't the problem right here. Then we would move to the next one, take it out, put the new light bulb in. If it didn't work, we'd take the new light bulb out, put the old one back in, try it again. Okay, so if you could imagine, if this was the 97th light bulb, I would have to check through 96 of these good light bulbs, and then I would finally get to this bad light bulb. Okay, so if this one was the problem that was acting like an open switch because the filament was broken, that means that if this was the open part right here, if I put in the new one, then my circuit would become complete because now my wires are all okay and they're all touching each other. Then my light bulbs would all turn on again. Okay, so I hope you understand this idea. These light bulbs would either be all on or all off. Okay, so all on or all off. If one light bulb is broken, all the lights turn off. So this was a really big problem, right? So these were all done in series circuits because manufacturing was much more expensive just because now the source of a lot of our goods are from a different country, right? So the idea here is that now that our manufacturing processes have gone lower, even things like wire and metal, okay, and also there were metal shortages at certain points, right, after the war. Okay, and I don't want to go into all that, okay? But the idea here is that these parallel circuits, which we're going to learn about next class, this doesn't happen. This sort of problem doesn't happen, okay? But they were trying to save on metal wiring, okay, which is why they did this in series circuits. Okay, let's keep going. So let's turn to page 130. Okay, so how many light bulbs are there in your home? How many other electrical devices do you have? Okay, so we have a lot of light bulbs in our home. We have a lot of electrical devices, microwaves, computers, what else? Ovens, TVs, printers, telephones, faxes, whatever. Maybe not faxes. Okay, so must they all be working if you want to use just one? So do all of these devices, microwave, TV, printer, computer, do they all have to be working at the same time if you just want to use one? Or alternatively, do they all stop working if you shut off just one? So if my washer and dryer aren't also working along with my, like, do I have to have all of them working all at the same time if I want to just use one device? Okay, so think about that. Okay, the answer is no. That would be ridiculous, right? That would be a huge waste of electricity. So the answer to both of these questions is no and no. Of course not. Homes are not wired in that way. But there are electrical hookups that work so that all electrical devices in the circuit are either on or off. This kind of electrical hookup is called a series circuit. Okay, so there are two important things to remember about a series circuit, and we've gone over them, but let's go over them a little bit more in depth. So number one, electrons or electricity, which is the movement of electrons, electricity or electrons have only one path to follow in a series circuit. Okay, so don't turn your page, but over here, there is only one path. There might be several devices, okay, but there's only one loop for the electricity to go in, okay? That is the definition of a series circuit. There's only one loop. Each electrical device is connected along this one path. Because of that, the electricity cannot go to just one device. It must move through all. Okay, so let's just see this. So my electrons travel through here. It must travel through also bulb number 1 and bulb number 2 and the switch. There's no choice, right? Because all of these are connected on one path. There's no such thing as an alternative path. Okay? If you turn off any electrical device, you will turn them all off. If you turn that device back on, you will turn on all the devices. Okay, so that means that if this light bulb is burning, is on, is lit up, that means that this one also has a chance to light up. But as long as one of these is broken, then the other one will also not turn on because there will be a break in the circuit. It will be a bad circuit. Okay? Doesn't matter that the second light bulb, if this one breaks or turns off, okay, the electrons, even though it passes through here, it has a chance to pass through here, because there's a break right here, the electrons will not even flow. They can't even get to this first light bulb. It doesn't matter that it is first in line. Okay, the electrons either flow or they don't flow. So as long as one of them is off, the electrons do not flow, which means there is no electric circuit. Okay, so please take a moment, pause the video if you need to, and you can listen to it again if you need to. Okay, next up, the electrical devices or appliances share the electrical pressure in a series circuit. This means that it shares the electricity. If you add electrical appliances, each one gets less electrical pressure. For example, suppose you have light bulbs along a series circuit. Then you add more bulbs. What would happen? Each bulb would give off less light. Okay, so that's another important one, and we're going to look at the phET simulation in order to prove this. That way we can really see it, okay? So why bother with series circuits? They don't make sense for homes, schools, and factories, okay? So can you imagine if when I turn off my microwave, then my lights turn off, my washer and dryer wouldn't work, my TV shuts off, okay, for example. Or think about also, like, let's just say I added more light bulbs, or I turned on several light bulbs in my house or in the school, and every time I turned on another light bulb, everything got dimmer and dimmer and dimmer, okay? It definitely does not make sense for homes, schools, or factories, okay? But there are special uses for series circuits. Parts of computers, radios, and television sets are wired in series. Parts of space rockets are too. Okay, and so some of these things are actually, some of these components are actually for safety reasons. So if something isn't working, maybe you want the whole device to shut down for safety reasons. Okay, let's turn to the next page. So here is an example of a series circuit. Notice that there is only one loop. So we're going to trace the path of the electrons in the circuit. So it will come out. So please trace this, okay? It'll come out this way. It will actually go through the light bulbs. It'll go through this other light bulb. It'll go through the switch because everything is connected by metal right here. Notice that this is a closed switch, right? The metal right here is making contact with metal, which is why this is glowing, or it's on, okay, it's lit. It keeps going through this wire, and then it returns back to the positive terminal. There's an electrical, there's a reaction right here, okay, which makes the electric circuit keep going. Okay, so in this electric circuit, how many paths do the electrons have to follow? Well, I'm not counting the number of devices or switches, okay? So I'm not saying, oh, it has 1, 2, 3, 4 because there's 4 items. No. How many paths are there? Well, there's only one loop. Okay, I can only put these through in one loop. So it only has one path to follow. Okay, is the circuit complete or incomplete? Well, everything is connected properly. My switch is closed. This means that the circuit is complete. Okay, I'm going to type it out instead. Okay, where does the electricity have to go before it reaches bulb number 2? So let's take a look. Here's bulb number 2. Where does the electricity have to pass through before it gets there? Well, it has to pass through bulb number 1. Okay, this means if bulb number 1 were to go out, so we talked about this, if bulb number 1 went out, bulb number 2 would also go out. Okay, and I hope that makes sense. It would also go out. Why? Because if there's a break in the circuit, it doesn't matter where it happens in the circuit, it's either all on or all off. Okay, now if bulb number 2 were to go out, so let's try that one next. Okay, so if bulb number 2 were to go out instead, bulb number 1 would, okay, so if there's a break here, it doesn't matter if bulb number 1 is before bulb number 2, it acts like a switch. Okay, it acts like a switch. It doesn't matter where the switch is, it would also go out. Okay, that's a little bit tricky, right? Because it looks like the electricity goes through bulb number 1 first, so maybe the electricity would get there, but that's not the case. In this circuit, each bulb is or is not getting the full electrical pressure. So this is a new type of question. So it is not getting the full electrical pressure because if I had one bulb, this would actually burn more brightly. Okay, so I'm going to say is not getting the full electrical pressure. If more bulbs were added to the circuit, each bulb would give off less light. If this circuit had only one bulb, it would give off more light. Okay, so this is kind of like some notes just because we're not too familiar with these answers since we haven't tried this out. Okay, we just know theoretically what happens. Okay, so I'm sorry, this video is running really long, but I do want to just show you this idea in the phET simulation. Okay, so let's go back to the PDF. Okay, click on the phET simulation link. Okay, press play. I hope we're getting more and more familiar with this. Plus, press intro. Okay, and we're going to put down, let's just say 2 batteries. Okay, just because we want it to burn a little bit brighter. Okay, let's put a wire here and let's put 1 bulb. Okay, 1 bulb for now. Okay, so please feel free to pause and add these things in as you go along. Okay, or you can wait for me to finish off everything. Okay, so let's take a look. Take a look at the brightness. Okay, take a look. There's only one path going through here. Okay, and take a look at this brightness. Now I want you to disconnect. Okay, make some room. Make some room. Okay, and actually, sorry. I think I'm sorry. Okay, I got rid of some components right there. I'm sorry if I'm hurrying along here, but I want to put the bulbs on top. That way it's easier to manage them. Okay, so let's go like this. Okay, I hope that's okay. Hope you can kind of catch up with me on this. Okay, so we can go like this. Maybe we'll put a wire between. Okay, so there we are. Let's put a wire in between here and then a wire between here, okay? So take a look at this. What happens to the brightness? I hope you notice that it actually gets dimmer. And you can even count the number of light rays that are coming out of them because this simulation is very accurate. There will actually be less light rays coming out. Okay, let's just undo this one, okay? Let's add in a third light bulb. So let's just see how bright this was. Let's remember what that looks like. Okay, and then let's cut this out. Okay, and let's add in a third one. Okay, take a look. It's even less rays, right? Okay, let's add in a fourth here maybe. Okay, so let's just shove things over. Fourth one. You can actually just connect them all. I'm sorry. This is like hard to see. You can actually connect them all together. I'm actually just going to add 5 or 6, okay? I'm putting each of them, snapping them in together. Okay, but I'm hoping that we really see the difference now. So now we have 1, 2, 3, 4, 5, 6, like 7 or 8 of them. And then take a look at the brightness. They're so small now, right? The little rays that are coming out because they would become extremely, extremely dim. Okay, now how do we simulate one of the filaments breaking or one of the light bulbs breaking, light bulbs burning out? We could simply just pretend that one of the wires has been cut. Okay, so what happens when one of the wires has been cut? Everything turns off. Okay, I'm going to reconnect it over here. What happens if I disconnect one of the wires here to simulate, one of the earlier bulbs? Okay, nope, doesn't matter how early it is. What happens if I get the first one right here? Nope, doesn't work. Okay, what happens if I disconnect the last one here? Do the electrons flow through all the other light bulbs? Sometimes it's a misconception that, hey, the electricity comes from the negative side right here. They're moving through here. Maybe they get through all the light bulbs and then they don't flow through the last one. No, that is not the case. Okay, so I'm hoping that you now understand the idea of a series circuit. Okay, so over here, all the electrons flow through one path. There's several devices, but there's only one loop for the electrons to follow. There's no alternative route, okay? Okay, so let me just go back to here now. Okay, so please, if you would like, you can practice these questions either on paper or you could also practice them online on the quizzes assignment. Okay, and here we go. Let's just do this. Let's just finish off this one. Okay, so let's just take a look here. How many paths are on this circuit? Okay, let's check it out. It comes out of the negative, goes through here, goes through the switch, returns through the positive. There's one path. Okay, let's take a look over here. These are using symbols, okay? But that's okay. This is the negative. This is the positive. So I know that the electricity is coming out of the negative. It's going through this closed switch. It's going through this light bulb. It's going through this motor. It's returning right here. Notice that there's only one loop. There's one path. Okay, let's take a look here. It comes out of the negative. The electrons come out of the negative. It goes through the bulb, goes through here. Okay, so over here it's open, but really there's only one path. Okay, similarly over here, this is a motor. That's a real live motor, okay? Light bulb, okay? One path. So these are all series examples of series circuits. Okay. Lastly, don't let's just skip this for now. Okay, so don't worry about doing these circuit diagrams. We're not going to be doing this just yet. Okay, so let's just focus. I want you just to practice the phET simulation. Okay, and then when you've reviewed the questions, or you can review the questions through the quizzes assignment, feel free to do it multiple times, okay? You can finish off the lesson there. Okay, that was like a 24-minute lesson. That's plenty, okay? Sorry for taking so long with that. I hope it's all understandable though, and I would like everyone just to try out that simulation, okay? Take care everyone and have a great day. Bye-bye.